Hey, thanks for watching this video. This is one class from the 2022 HVACR Symposium in Claremont, Florida. We have the symposium every year, and so to find out more information kind of upcoming, go to hvacrschool.com/symposium. Big thanks to our sponsors for this event, which was AccuTools and TrueTech Tools. They're the two title sponsors that made the event possible. This isn't really a class, but this is just sort of a fun, free-flowing session that I did with my good friends Joe Shearer and Eric Mele, doing a general Q&A on all kinds of different technical topics.
At the far right, we have, I feel like I'm doing this like a wrestling match, you know. On the far right.
You're on their far right.
Oh, that's a good point. So this guy over here, Eric Mele. Eric is a commercial technician. He works with us at Kalos. He does everything from grocery refrigeration nowadays. Actually, that's probably the majority of what you do nowadays, right? Are you gonna speak like you have a microphone?
Yes, but
yes.
you're speaking. I didn't want to speak over you.
Okay, all right. That's very unlikely. It's very unlikely. So Eric's done just a wide range of different things from refrigeration, air conditioning, the water side. Has a broad set of knowledge, and is kind of our top commercial technical mind at Kalos. And then we have Joe or Joey. What do you prefer to go by, Joe or Joey? Joe, Joey,
Just Joseph. Robert.
Oh, Joseph.
Yes,
Okay.
it sounds really smart.
Okay, yeah. Joseph Shearer III, Esquire. Joe owns and runs an air conditioning contracting company up in the Tallahassee area, and Joe he has an additional career being a troll on YouTube, in addition to his own YouTube channel. He's well known amongst all creators as the guy, when you do anything wrong, he writes, "Well, actually."
No, I'm.
Well, actually.
No, well, actually.
Well,
actually, I'm trying to be helpful. I just come off that way. So.
It is. Actually, Joe is everybody's favorite naysayer because he always has good feedback, unless he's talking about pinching off a discharge line on a compressor in order to test it, which is the most ludicrous thing I've ever heard you suggest. But we can talk about that later if necessary. We did this last year.
I'll save it.
Yeah,
for
yeah.
later.
It's one of my favorite. Yeah, one of my favorite edits I had to do on a podcast was Joe suggesting pinching off a discharge line.
It's not safe.
It probably is fine, but it just seemed like a radical thing. Anyway, we're not talking about that right now. So we have Caleb, who has a microphone over here. So if anybody has anything, now say it. If you want to ask. Otherwise, I'm going to start on my list of online requests. So anybody got anything right away that you want to ask? It's just burning a hole in your soul. Or do you want us to get seating here? Okay, we'll get started. And then if you have anything, raise your hand. Caleb will bring you the mic. Even if I'm still speaking and you think of something, just raise your hand. All right, so the first thing I'm going to ask these guys is about line set cleaning. Because that is actually, Joe is probably the original, the OG guy who started using pigs, specifically pipe wiper product, in flushing line sets and was like a big advocate for it. Actually, he's the reason why we started doing it at Kalos. So I kind of want your broad perspective on it, how you kind of got into using that and sort of what you've practiced.
Replacing line sets to me was a lot of work. And I'm
only to you, not to everybody else. Everybody else, it's easy.
How? Yeah, I've seen those easy ones. It's like, oh my gosh,
Yeah. You
Yeah.
said to me replacing line sets is a lot of work. For the rest of us, it's a piece of cake.
And I say that because some companies, that's what they do. Every install gets a new line set. Obviously, sometimes it's not even possible. So I ask, and then they would probably buy a can of flush or empty a bottle of nitrogen and feel like they've done something. But I'm always just, I guess I have a critical mind, and I'm just if it's not coming out the other end of the line, did it clean anything?
Well, you're right. How could it?
Right.
Which is the same thought I always had. Like, if you're cleaning a line set and you put RX11 or Pro Flush or whatever branded solvent that you're putting in a line, or nitrogen, and you look at the end and nothing comes out, you didn't clean it. I mean, right?
Right, and some of the flushes are so or they boil at such high temperatures that nothing actually makes it out the other end.
Low temperatures. They boil at such
Okay,
low
right.
temperatures. Right.
Okay,
Right. Yeah.
sorry.
They're volatile.
I'm
yeah.
nervous.
No, it's good. No, it's
Yeah,
fine.
well, they're-
You're not nervous.
So RX11, the Pro Flush actually comes out the other end, but it's usually clean. You know, it's always clean. And the challenge is how am I going to get the flow rate to really clean a 3/4, a 7/8 line with this little 1/4-inch nozzle, you know? And I was always trying to devise something like, could we hook like the way they clean Renai's is like they hook that transfer pump into a bucket. It's like that would be what it would take to really clean these lines. And then the pigs came out, and I started using those in conjunction with the chemical flush, and I feel like that is the perfect pair.
So have you always done both?
I
always
tried
done
when I first got the pigs. I tried them by themselves.
And when you're saying pigs, specifically, you were using Pipe Wiper. That was the
Correct.
brand you were
Yes.
using. Okay.
yeah,
Yeah.
but they were the only ones at the time.
At the time, right.
Yeah.
Right.
And you know, like my father, who was an old school mechanic, was like, "You are not going to put those in the lines." I was like, "Yes, I am." You know?
I guess I will, Dad. You do not tell me what to do.
Yeah.
Yeah.
And it was like, they say if they just, you know, it makes sense. If it gets stuck, we're just going to blow it back the other way. It got there, it can get back out. It's like, okay, you know. And he was real concerned about the particles. You know, the little, if it
Yeah,
were
little
to,
pieces, yeah.
little pieces, but we're going to get those out because we're going to put some high pressure nitrogen behind it.
Yeah.
And take care of that. So it was just that quest to see something dirty come out of lines that really.
You just want, it's that quest to see something dirty that gets you in a lot of trouble in your life. You know, starts as a teenager and gets worse from there. All right, we got a
It's
question.
truth.
Yeah, it is. It is.
How often have y'all had like the actual pigs fall apart in the line set? Do
Well,
they
they-
normally come out whole like in one piece, or are they chewed up, gnarly?
They're always in one piece, but sometimes you'll have little fragments of the foam in your. Because I usually try to catch the chemical and the pig.
Yeah.
That way you can like see if it's clean or dirty, and there'll be little black flakes in with the flush chemical, and that's typically because when you're gonna, you know, how many people usually don't ream copper real well, so it's sharp.
Yeah.
And it's going to kind of be cutting that pig a little bit, but it's never been in two pieces or
Or big enough pieces to actually like clog a TXV or anything of that nature?
I don't think no.
No?
I always follow it up with a good, you know, purge of just a dry nitrogen at the end, and if there's a little tiny, I feel like a little tiny piece of that pig is better than a totally
Dirty
carbonized oil line. You know, I feel like I've done better getting all that nasty oil and
Leave it
carbonized oil,
Yeah.
because that's what the black coating is when you look inside an old line set and it's black, is carbonized oil stuck to the copper out of it.
So what you're saying is sometimes they come apart a little bit. The main reason, if you're not reaming or deburring the copper on the entry side, that can cause damage. So you should do that. You should deburr or ream the copper on the entry side. But another thing is that was kind of one knock that I had on the pig design from Pipe Wiper, is they weren't real consistent, and so I think that led to some of the damage. And they were also pretty. They weren't super dense, and I think that led to some of the damage. So the ones that Hillmore have are a little bit more dense, and they are manufactured a lot more smooth. It looks like a completely different manufacturing process. Now, again, we kind of have to see through a lot of testing whether or not that impacts, you know, how they work. But in preliminary testing, it doesn't seem to. They seem to be as good or maybe better than Pipe Wiper. But what are your thoughts on that?
They seem to be, yeah. I'm excited to try it. Obviously, it's a very new product, so I'm excited to see if it's, you know, how it performs. I do think you'll see a little bit of the black of the pig still,
Yeah.
if you're looking for it.
Yeah.
But
But blowing it out with nitrogen after you run the pig through. Just keep running the nitrogen. That's the best practice. And again, in terms of like the common objections are, what if they get stuck? So have you ever had one get stuck? I'm asking Joe this because he's been doing this as long as anybody. Do they ever get stuck?
Yes, they get stuck.
And then what do you do?
Well, you can crank the pressure up and try to get it through. Or if it just will not go, you got to blow it back the other way.
But have you ever had it where you couldn't get it out?
Get it back out?
Yeah.
I've never had it not come out.
Yeah. And that's the same with us, too. Because what people will say is, well, what if it's a 500-foot? I don't know why I always do this voice when I'm doing what people say. That's kind of insulting. Yeah.
Yeah, because
I go to my Groveland, Florida boys. It's like, hey there, buddy. I don't know what happened if I never get that thing out of here. No, that's Cajun. I sound like
I ain't never had a problem.
Right. I never had a problem, and I've done it for 4,000 years. It's like, hey, you weren't even alive that long. That doesn't make any sense. No, so the people imagine that it's going to get stuck if it's this really long distance. But that's something I want to address too, because that doesn't matter, because you actually are building static pressure behind a blockage. People imagine it being like pressure drop due to flow pressure, but it's actually just a question of volume, unless I'm not thinking of this right, but I'm pretty sure I am. It really doesn't matter how long the line is, because it's the same thing they use when they're cleaning like oil and gas pipelines. They use these gigantic pigs and they blow them for miles and miles and miles down the lines. You have a static pressure buildup, and so it's just really a question of nitrogen volume. So that's not a factor in getting it stuck. The only thing that could get it stuck would be a really bad kink or somebody who did something nutty, which I kind of want to ask Eric about that, his thoughts on that. But in that case, you can always flow it back the other way. Like it's not on our side, we've probably done 2,000 installs in that range with pipe wiper at this point, and we've never had one get stuck that we couldn't get back out either. So,
yeah, I haven't had. Maybe that day will come where it's just the perfect storm of a certain bend that it is really stuck and I can't get it.
So I want to talk about, because Eric had an idea of where he thought the worst case scenario would be. We tested it and it seemed to be okay, but
For the small test, at least, that we did here, it seemed to be okay. But my thought is, if there was a bigger section of pipe that had a smaller section of pipe on each end, that when it would go into the bigger section, now it's in there and the nitrogen's not pushing it enough, and it's not going to be able to get just blown backwards because, for example, the trainer I made out there, you can see them, and it does make it through. It's 7/8 into 1 1/8 and then back to 7/8, but it does, in fact, come out of that. But I believe if you did have a big enough difference in pipe size, it could get stuck, and so does the guy from Hillmore, but the likeliness of going up 2 or 3 pipe sizes, it could happen, but it's very unlikely.
Yeah, or it could turn sideways in that. It could turn
In that
sideways
space,
in
yeah.
that space
Yeah, in that
and
space,
get cooked.
yeah.
But my plan of attack for that situation is I would have to start to get some really big volumes of nitrogen going through that line, because at some point it's going to carry that pig to the next place, and it's going to start to push it through that section. So
I think it's more like all of those puzzles. When it's a really tough situation, you always spin it. That's always the answer. You guys know what I'm talking about, right? Like it's like you get those puzzles, you just spin it. So you just have to spin the copper lines. It's simple. I'm just being ridiculous. Keep going. just being absurd. I just feel like we're going
I want to see this happen.
No, my point was
I want to see
I'm
you
being
spin the
ridiculous
copper line.
because I think we're being a little ridiculous to try to come up with a situation in which, when literally none of us have ever run into this and it's never happened.
Right, but I think anything, should you find yourself in that scenario, your answer is going to be get the flow up. If you have to, let's say worst case scenario, you're going to have to put 2 Schrader port, you're going to have to solder them onto the outside, put 2 on, get 2 tanks of nitrogen, 2 regulators, and just get the flow, you'll get it out. I feel like.
Yeah, I agree.
That should be your plan of attack, is like, okay, we are going to have to use some aggressive solutions to get this back out.
Or you could do as Missy Elliott suggests. Never mind. Keep going. All right. So, you guys know where I'm going with that? Okay. All right. So, the other thing I wanted to ask about was kind of your flush strategy, because you do some weird things sometimes when you have like different orientations of the copper. Like if it's pointing up, because that is one of the challenges, especially with pipe wiper, is like if it's coming down out of the ceiling. Flushing that is kind of tricky if you're going to use if you're just using the pig, that's one thing. But once you use the pig with a little bit of chemical, you do see how clean it gets it and how much comes out, right, Burt? Yeah. I was just checking to see if you were awake. Yeah. Okay. And so, but putting chemical in when the copper's pointed down is actually pretty challenging. So anyway, that's over to you.
Yeah, definitely. If you can, I've like had to make a big U out of the copper, and then kind of get up on a ladder. So if like let's say the unit's on the roof, or it's not on the roof, but it's outside, and the line set goes up into the ceiling and out, you can usually try to make a loop out of it, so you can pour the chemical flush in. Hopefully we'll devise a plan of a more easy solution that you can kind of inject the flush ahead of the pig. But for right now, you're kind of stuck with that, trying to get the line set to go. Also, if it's just impossible, you can always go from the outside in, but I advised against it because you're going to...
Yeah.
You can contain it, but the smell is pretty strong, but,
Right. Well, what you do then is if you just fart to cover it up.
That's what you do?
Yeah, that's what I do. I just let one rip inside the house, and then I do that, and that covers up the chemical smell.
Dude, that's smart.
Yeah. Hey, look, modern problems require modern solutions. Yeah.
Just hopefully that doesn't light off the cloud of...
I don't know why you're changing the subject here. This is a professional Q&A session. I mean, this is ridiculous. All right, so I think that's all I wanted to say about that, unless you guys have any further. Oh, Eric, I wanted to ask you, because you in the past have been somewhat resistant to it, somewhat. So why is that? What are your thoughts about it?
Probably similar to a lot of other people, just thinking, I'm going to get this thing stuck in there, and now what am I going to do? It's just going to make my life harder. Mm-hmm. But even after, trying to get it stuck with somewhat reasonable means, it's kind of takes that away.
Okay.
So, seems like a good option if you don't want to change the line set.
Well, my thing is, too, after doing it as much as I have and knowing how bad it has to be pinched to get it stuck, wouldn't you rather know that? I've had cases where it's usually on brick houses.
That's a good point, yeah.
It's usually on brick houses where the line set's running down the wall, and the brick masons always are just like, when they...
How's that? How?
You're like, this line's coming out of the brick, and we need it straight out. So, whenever you see a copper line come straight out of a brick house, I want you to be very leery of what's behind that, because it's so often that's right where my pig is. You can hear it. It actually makes us. It's a very.
I tried to make a pig noise and it didn't work.
No, that.
I just went, I can't do it right now. I don't know what's going on with me.
It's not the.
It's like an inhaling
it's not the
noise,
like the
and it wasn't
boom.
Working. Yeah.
It's like when that you can hear it from the attic. When I'm in the attic and the pig comes out, it's like. You can hear that.
Yeah.
Is that good?
Yeah. No, that was exactly what it sounds like.
And then if it's stuck, it's like. It's the pressure of your nitrogen going around that pig. Mm-hmm. It makes that noise. So I'm like, I don't even need. You have to have two people to do it my way, because I'm trying to get someone to catch the chemical and the pig on the way out
in their hands.
I can hear.
Because if you do it by yourself, it's really hard, because you got to shoot it and you got to run really fast.
And I'm like, it's like.
You're doing it all wrong. You just need a longer nitrogen hose, so you can be outside. You have your 100-foot nitrogen hose going inside, and then launch and catch.
Here it comes. Here she comes. Just face right in front of the suction line. I think I see it.
Yeah. I have a funny story about that.
Okay.
My poor dad.
Oh no. Okay, go ahead.
We were doing it was like a long line set, 1 1/8, and it must have had a bunch of dips, and the system was totally flat. And just put some nitrogen in it and found a massive leak in the evaporator, so we were going to change the whole system. So we went to do the pipe wiper, and all right, Dad, I'm going to send this one through. You ready? Yep, I'm ready. And
famous last words.
All right, here it comes. And on the other end, all I hear is, "Oh my gosh!" And I'm like, "What happened, Dad? Hello?" Because I'm usually like on my headset talking to him, and I go outside, and it's like, "What happened?" Like oil everywhere. There was like saturated on him, all over the other units, all over the ground. I'm like, oh my gosh. Like, he didn't look like he hated that stupid pipe wiper thing. You know? Like,
He hated it in the first place, and then you made him use it, and then you doused him. Yeah.
so I'm like, wow. I'm glad we got that oil out, Dad. And he's like, yeah.
Yeah. Exactly. It's like, well, this is why we needed to do it. I mean, we needed that out of there.
No, but I'm like, are you okay? He's like, I think so. Like,
Don't worry, it's just caustic solvent over your face. It's
well,
no problem.
that was mostly oil.
Okay.
Like it was
okay,
just
mostly, yeah, it's fine.
yeah, it was just mostly oil. Like I did not put as much as he was covered in.
Yeah. That's
in
kind of
oil,
like
it
a
was
brownie
like-
that's mostly brownie. Yeah.
Are you feeling okay, Dad?
Don't worry.
Yeah.
Don't worry. It's mostly brownie. All right.
So the moral of that story is warn the guy.
Yeah. Well,
And-
I think the ideal thing is to put it over an oil pan. So I've thought about this. Over an oil pan. Well, you already have an opinion. Yeah, you're already looking at me like I'm stupid. I can see it. No,
I'm
it's
ready
fine.
to hear
You're
it.
looking at me with that YouTube troll face. Like, well, actually.
Well, actually.
So you put it over a oil pan, and you just like put a rag over it with the catch net. That's my thinking.
Yeah, I mean, I try to get like an old milk jug or something where I can kind of just cut a little opening, so it's not like as much of a place for it to like bounce out and splash out. Like a big oil pan, I wouldn't really want to be holding that.
No, you're not holding it. I mean, you have it underneath it, and you have a rag.
You got to kind of hold it though, or else it's just gonna blow it off.
Yeah, but okay, yeah.
Yeah.
I mean, it will, but
And that's what I'm like. All right, you gotta, that's why it was covered in oil.
okay.
So he was right there.
Right. Yeah, he was ready to catch her. Yeah. Okay.
So and that's what's great about it is you can devise your own way to do it, and there's no right or wrong way as long as it works for you.
That sounds very, very existential. You know, we all have our own truth about pipe wiper.
Yeah, there's some things that are truth and are not truth, but whichever way you want to
know,
catch the pig,
Look, pursue your own happiness as it relates
Hey,
to
man.
wiping pipes. You know,
wipe them, don't wipe them.
whatever you want to do, man.
Leave the pig in the line.
Yeah. Yep. I just couldn't get it out. I mean, I don't know what to tell you, boss. I tried to run it through the TXV and it wouldn't make it through.
I tried to clean this TXV.
That's really not fair because I am using a specific person's voice there who I used to work with.
You said you wouldn't talk about it.
I don't know, boss, but it just wouldn't go through. Yeah. All right. That's mean. Okay. This is a question that was submitted by somebody. I actually forget who it was now. I don't have it written down. Is there enhanced wear and tear on heat pump inverter compressors that run a great deal more at higher RPMs for heat mode operation due to being located in, say, climate zone 6 versus 2? So you can tell this is one of these building science nerds. They're talking about climate zones.
Which
So, like,
climate?
look,
Where is that?
Look, there's two places. There's Florida and then
Canada
there's everywhere
versus,
else.
versus like Florida.
Yeah, it's cold. Cold places. Cold climates versus warmer climates.
Which one's the cold one?
The cold one is the higher number. Yeah, the higher number. So the question is there additional wear and tear in those circumstances?
Yes.
Can you
Next.
please quantify it in wear and tear quotient? What is the...
So you're saying you're increasing RPMs to have a bigger compression ratio because your outdoor ambient's real low, you're running in heat mode, which is
Right.
known to put more wear on compressors when you have a high compression ratio and higher speed.
Yeah,
So-
but I think it's worth mentioning that the reason that often they can do that is because they have some form of vapor injection. So like they usually, not always, but they often nowadays are having some method in order to deal with that interstage or whatever in order to keep the compression ratios reasonable. However, to the overall point, yes, when you spin things faster, you have higher compression ratios. That means you have hotter compression chambers, depending on the compressor technology, and yes, they won't last as long, but I think that goes back to kind of what I was talking about yesterday, is it depends on what you design it for. So if the manufacturer designs the thing under normal run cycles to last 10 plus years, well then, or more than that, you can design a compressor to last for 50 years. I mean, we know this because there's 50-year-old compressors out there that are still operating. So that's kind of my take on it. What do you think, Joe?
Yeah, I would think it's subjective as well. I would,
There's a
I
lot
don't
of
have a lot,
subjectivity
you know,
going on with you right now.
Obviously, I don't have a lot of experience in climate zone 6, being a Florida born and raised. But yeah, anything mechanical, if you spin it harder, and it's almost like in those instances, they're almost using the compressor windings as auxiliary heat in a way to kind of.
Well, no, I mean, obviously, if you the compressor windings are running hotter, but that's not the significant factor.
Right.
The significant factor is you're just moving refrigerant faster. You're increasing your mass flow rate.
But if it's got good software built into the computer, and if the discharge sensor is getting close to XYZ, it starts to fold it back. It could work and not necessarily be a significant factor in, like, you know, this unit only lasts 3 years and compressor dies. Because
I hope they keep doing that this entire time with that really noisy thing. I like that.
that's called a drill.
Oh, is that what that is? I was wondering what that was. I've never used one of those. I always use the hand crank thing. It just, you know, this guy right here.
If you've ever found strip screws on a unit, it's
It's me, yeah. All right, I don't think there's a whole lot else to say about that. Any other comments? It was just one of the questions that was submitted. Remember, audience, if you have any questions along the way, anything you want to ask, this is a total free-for-all. You can
maybe
ask
we're
anything
wrong
you
and you
want.
want to heckle us. We're
You
open
can
for
heckle
that.
us. That's fine. If you want to throw a mater at us,
What?
a mater.
A toe mater?
Yeah, a tow mater, yeah, of course. All right, let's see here.
Got
We
one.
have a question. Yeah, wow, that's
First
amazing.
question. Woo!
Mr. Bill Russell.
Hey, what do you guys, or what are your thoughts and opinions on non-cascading CO2 systems being operated in Florida?
Non-cascading CO2 systems being operated in Florida. So you're talking about transcritical,
Yep.
A transcritical system. Yeah, it doesn't really work. I mean, when you get over 86 point whatever degrees Fahrenheit and you go transcritical, it becomes inefficient as a refrigerant. It's not that it can't work, but it becomes difficult from efficiency standpoint. So we can't use adiabatic cooling here because our relative humidities are so high. So in markets that are dry and hot, you can actually use some adiabatic, pre-cooling in order to stay below that 86 degrees. But here we work on, in our grocery space, we work on an infrastructure that uses CO2 essentially as a secondary fluid. I mean, it's using it almost like glycol. It has some additional, latent heat properties. But so to answer the question, any type of transcritical system is going to work best in lower temperature ambient climates or climates where you can use some sort of adiabatic cooling, meaning evaporative cooling, in order to kind of keep it down below that 86 degree point. We just are kind of the perfect storm where neither of those are great. Now, do I think that technology could advance and change? Sure. I mean, I'm sure they can, and they probably will figure it out. But as we stand right now, I don't know of any transcritical CO2 systems in our market.
Well, I have some news for you. We're building one in Jacksonville.
Oh, okay. I should have asked Eric, who actually does this work. Tell me more, Eric. Actually,
Yeah.
Don't tell me more if we're not supposed to say it because of our
I won't
customer.
say the customer,
Okay, all right.
but the customer, Nathan bid the job and we were awarded it, building a transcritical CO2 system in Jacksonville.
Jacksonville
Pretty north.
being the furthest, one of the furthest north points that we're going to
So.
work in. So, yeah. But again, you can do it. It's not that you can't do it. It's just a question of efficiency. Once you get above 86 degrees, you do lose efficiency. So.
But you said there were going to be some mitigating systems to take care of that if it does reach that point.
I haven't seen the plans. We could maybe do more on this later. I'm very interested as well to see how they're going to implement it, but it is going to be evaporative cooling and water-cooled condensers, obviously.
Oh, okay. Well, there you go. I mean, so you could also do water cooled in Florida. Yeah. So if you're in an environment where you can use water cooled, then that also helps solve the problem. Yeah.
Well, it's
I
going
don't
to
tend
be
to.
a cooling tower, water-cooled condenser.
Yeah. So there are options. Does anyone else answer the question? I was really rushing through that. I couldn't say the word answer for some reason. That's tough. Oh, is that what you were doing? Oh, you were trying to give us a gotcha, weren't you? That was a gotcha, wasn't it? Oh, okay. So that was a softball question. Oh, okay. I like those. Thank you. Okay. The next thing is Corey Cruz, and this is tongue-in-cheek, and I'll describe the story here soon. He says, we need to let the people decide once and for all if sensing bulb position actually matters. Do you know why Corey's asking this question? No? Do you know Eric? Okay. So,
Do tell.
yeah, I'm really, really dragging this out for absolutely no reason. We just have a long session here, so we got to really fill it in. No, and so about 3 years ago, I was in this refrigeration group. I don't remember which one it was, some grocery market refrigeration group. And somebody saying, maybe it wasn't. Maybe it wasn't even in my group. I'm not sure. No, it wasn't in my group because I was being, I get especially sassy in other groups, just not in my own. In my group, I act like really professional, like, I can't believe you would say that. And then other people's groups, I act like a jerk, kind of like how Joe does, sort of like that. But anyway, so I was in this group, and they were asking something about some issue, and it was like it was an issue that was like a low superheat type problem, I think. No, sorry, a high superheat type problem. And this kid comes on and says, "Did you check bulb position?" And Jeremy Smith, who's like, you know, the grouchiest, best, awesomest old grocery tech that there is, comes on and says, like, bulb position's not going to affect that. Like, it's not, you could put it pretty much anywhere on that suction line, given the size of it. You know, it's under 7/8 or whatever the case. It was a smaller application. It's not going to make a difference. And Corey comes back on and is like, oh, so you think you're smarter than the manufacturer who says that it has to be, you know, whatever, 10 and 2, or it's not 10 and 2. What is the standard thing they say? If it's under 7/8, they'll say right on top, and if it's 7/8 or over,
It's
they'll
like
say
the 3 or the 3 or the 9.
3 or 9. Yeah, I think it's kind of typical. And so he kind of comes back at him hard, and Jeremy Smith comes back with, "Listen here, son." That's the next line. You know, come sit on Grandpappy's knee while I teach you something. Like it was literally that strong. And so it starts this sequence of events where he's like, "Do you even know how TXV works?" He's like, "Of course I know how TXV works." So he says, "Well, tell me the three of the forces that impact a TXV's operation." And he says, I don't know what you're talking about." He's like, "Exactly." and so he says, "I don't know, Freon, airflow, and voltage or something like that." And so everybody just attacks. So just like jumps in, you know, just like we do, blood in the water. And basically, and so I'm telling this kid, I'm like, "Dude, like, don't, like, just back off. Just like back off and listen, because there's stuff going on here that you're not." And so he starts like, "No, the manufacturers say," and he starts pulling screenshots, and so it's this whole thing. Well, fast forward to like a year later, my brother's like, "Oh, hey, I hired this new kid. I really like him. His name's Corey Cruz." I'm like, "Oh, that's interesting." So he comes in for orientation or whatever. I'm like, "Oh, hey, remember the conversation about bulb placement?" So anyway, that's a really long story.
You're fired.
Yeah. Well, no, so it got a lot more caustic than that. It was like where he was calling me names and I was calling him names. It was a lot of fun. They were good names, really good names, made up names. And so, but it was fine. So anyway, Corey is now like, he's an excellent technician and probably one of the best young techs out there. And so he's facetiously asking this question.
Yeah,
but
this was a jab at you.
Kind of. It's just a jab in general. So the question is, does it really matter where you put bulbs? How you place a bulb?
Well, I guess in some large commercial stuff that I don't really have a lot of experience on, it can. But with the modern TXVs we have now, they don't really have the same chemical or refrigerant in the bulb that would cause the issues that kind of keep this. Because I've heard about the bulb, I've heard that when you have the little tail coming out of the bulb, that needs to be oriented down like a tank. Like, you don't want the capillary line running to the expansion valve head to be at the bottom, because then what could happen is the liquid that's supposed to be filling the bulb could like drain down into the expansion valve head, and then they call that charge migration of the bulb charge migration. And at that point, you will have high superheat when the charge migrates to the bulb like that.
And I've heard that too, but it doesn't really make a whole lot of sense to me. I mean, I think there can be stack effect associated with kind of the stack effect's the wrong word. What's the static regain? That's the term I'm looking for. When you actually have a column of liquid, But we're dealing with a liquid vapor mix anyway. So this idea that it's not going to impact. I mean, that would be like saying putting a refrigerant tank upside down or on its side, or is going to somehow affect the pressure that you measure coming out of the tank. Because that's all a bulb is it's just exerting a pressure. There's no flow.
But you need that liquid to be in the bulb to give it the proper, to sense the warmth of the suction line. Especially when the valve can be cold because it's surrounded by a really cold coil and the valve is cold.
I guess I see what you're saying. Yeah, it seems like that requires this. It seems like this requires an experiment almost to kind of see.
I've seen it happen. I've seen it.
Oh no, that's the old timingest thing ever. Like, look, I've done it this way for 20 years and I ain't never had a problem. All right, my daddy taught me that way.
I do believe it can happen, but I don't know that it's going to happen anymore with the cross charges and stuff that they're putting in the bulbs these days. There's no liquid anyway, so I don't think it matters. Although out of habit,
I mean, that's not always true that there's no liquid.
What's that?
I don't think that's always true that there's no liquid. Is it? Is that true?
All the modern like residential air conditioning stuff it's like cross charge, X charge, all the stuff that's like not.
Yeah, but that's
liquid.
not. No, but then there's still liquid in it. There's still liquid in it.
Are we having another?
Yeah, we are having a dispute.
Are you
here,
100% sure?
Yeah, because otherwise, it would have to be, because otherwise you'd be dealing with the you'd be dealing with the ideal gas law then. I mean, it would have to be.
They do some weird stuff with this little desiccant block that's in there, and it absorbs it and then desorbs. So what? I'm just saying. I'm pretty sure there's not liquid in a modern residential or like commercial air conditioning valve.
Anybody have any feedback on this? Any thoughts? All right. Yep,
Yeah.
sensing bulb. Yep.
Sensing bulb. That's what we're talking about.
How did it do that? Yeah. I mean, it's proprietary. Yeah, proprietary. Yeah. Yeah, that's a big
So he's
word.
saying it's.
This is ridiculous. I know. Yeah.
It was basically tannerite. I think.
Yeah. Yeah. I don't think that's a wise thing to put in there. Well, we don't have to tell you. Yeah. Be like,
We had a guy in the factory.
No, but this is when you use empathetic communication. You say, you don't have to tell me, but don't you want to tell me?
See, that's why Bryan gets all the answers.
It is. Yeah. No. Okay.
Smart.
Yeah. No, I mean, there's no doubt. See, this. Yeah. There's
we'd
no
have to
doubt
have
that
someone-
there's liquid vapor.
There's no
elements in this.
doubt?
Yeah, there is no doubt, because it's the same. It's the reason why when you have a limiting charge in there, that's how a valve becomes pressure limiting, which it hits a point where now there is no longer any liquid, and so now it no longer follows that linear.
But I'm
curve.
telling you, they have like this little desiccant block in that bulb.
No, I know that there's a block in there. I don't think it's a desiccant.
That's what they call it.
They do?
Yes.
Well, you would know better than me.
That's what they call it. And from what I've been.
Yeah. Proprietary.
And it's.
Didn't you hear the man? He's trying to tell you right now. Would you just listen to him? Stop arguing with him? It's proprietary fluid. Yeah. All right. So moving on. Let's talk about. So all right. So I think so. We're gonna hold out because Jim Bergman says the same thing about it going back into the head and all this stuff. So.
But so let's just answer. You're trying to
It's
answer the
position.
question.
Really, what the question
does
is
it matter if it's on a horizontal, vertical, tail
side.
down, tail up, sideways? I'd say not as much as it used to. I think the most important thing that you guys could do is make sure it's getting a good contact on the line.
Right. Clean and tight.
But not just tight, because sometimes I'll take my flashlight and I'll shine it through the clamp, and you see that it's not touching the line, and it's tight. The copper's a little bent. There's something kind of holding it. So you just want to kind of, move it till you can really not see a bunch of light coming through in between the bulb and the line, and just that's, I think, more important than any sort of orientation. But you know, the manufacturers do always say prefer horizontal if you can, vertical's accepted, tail up. Now, does that matter? I don't know.
So our answer is we don't know. But in terms of the placement and the clock position,
Yeah, I don't.
that's where, unless it's very large, because the only reason clock position could matter would be if you have significant residual oil, where that's impacting the temperature, or there's like stratification where the actual lower part has, you know, the interface between liquid and vapor, and that lower position would be a lower temperature than higher in the tube.
Yeah, and that's like a
I mean, it
very
seems like-
strange thing to experience. You probably, if you were to see that, you probably only see that once in your entire career.
Yeah,
that
and
actually affecting you.
And the point is that this or this tail wise could make a difference, but really having it tight, having really good contact between the bulb and the copper, potentially even insulating. I mean, when in doubt, and this is actually another question. I'll ask you, Eric. Do you think there's, because you haven't been talking much, do you think there's any downside to insulating a TXV bulb, even if, say, the factory did not insulate it?
It really depends on if the location of it's going to affect the temperature a lot, because some of them are outside the evaporator in a non-conditioned space, and in that case, you really want to insulate that pretty good if you want to get the temperature of the line. Like, I know Rheem is a big one for this. They give you the bulb, they want it outside the unit, and they give you a piece of insulation that's about 1/8 of an inch thick. And if that unit's in an attic, you probably want to insulate that thicker.
Yeah, but my question is, let's say you have a case where you're measuring your superheat and it's measuring on the low side. Could you argue that even if the manufacturer doesn't insulate it inside the cabinet, that insulating it would have some benefit?
I mean, you could try and see the effect if it's directly in a place where it's going to be affected by temperature, like in the airstream. Some of them are on the front where they're not really in the airstream, so probably not too much there, but if it is anywhere in the airstream, it's a good idea to be insulated from that.
Thoughts, Joe?
Yeah, like on Carrier, they like to, on the slant coils, they like to put that bulb right where the penetration for the line set is. And how many people always are great about putting those grommets in the doors? No one, right? So it's in an attic.
You didn't give me a chance to answer. I'm always great about it. Always. I'm the exception to the rule. Keep going.
But yeah, most people don't.
Other than me.
And when it's in a hot attic, that hot attic air is going right in that hole, right on that bulb. And I've seen that cause zero superheat. And
yeah.
all I do to go from zero superheat, and Carrier runs low. They run like sub 10 sometimes.
Yeah.
And all I've done is just, seal off that hole, and it'll go from 0 to 6. It's like, wow. So, yeah, there's circumstances where it can matter. And times where it doesn't matter, because it's, if you start to, with all the Measure Quick and the field piece wireless probes, you start to see things and that you've never seen before. And you're like, wow, on some of these really high SEER systems, that supply air temperature tracks your suction line temperature like within 1 degree. So if it's in that airstream, it's not going to matter so much.
I see what you're saying.
Yeah.
Because the supply air temperature is so close to
the suction line temperature.
right,
Yeah.
Right. Well, but that's not really supply air temperature where that's located. I mean,
You got some radiant cooling and stuff.
yeah,
but
there's just some other things that are going to impact in that location. It's kind of pre-mixing. Anyway, yeah. So I guess the point here is that
it can matter. Yeah.
the point here is that we're maybe focusing on the wrong thing. If we're focusing on clock position. Unless you're working with really, really big suction lines. Yeah, that's my take.
But while we're on the subject of TXVs and insulating the bulbs and stuff, inside, outside of cabinets, an important job of a TXV these days is also for off-cycle. It almost acts like a liquid line solenoid.
Yep.
In the off-cycle, which means it's going to stop all that really warm liquid that's outside in your condenser from going into that cold evaporator. And then the next time the compressor comes on, it gets a huge slug of that
Yeah.
liquid.
Slug was the right word. You see how we both use the same word?
Jinx.
How's that?
I have a question.
You got me. Okay, go ahead,
Do
Burt.
you guys have any practical tips for identifying liquid line restrictions? Sometimes they can be tricky because they don't show up with a temperature drop. I didn't know if you knew any practical ways to identify a liquid line restriction when you can't measure a temperature difference
That's a
across
wonderful
that
question,
restriction.
Burt, and I'm glad you asked that.
Yeah. Burt has always been a bad boy. Like, ever since he was a little baby, he's been like this. So, we'll get to that. I want to finish what you were saying about
He's already
it.
getting hot.
No,
He's already hot.
No, I do. That's a good question. We will talk about that. But I want to finish the whole thing about hard shutoff or non-bleed expansion valves, because that is one of my favorite topics of why an expansion, what makes an expansion valve non-bleed, why or hard shutoff.
Yeah, how does it know?
Yeah, how does it know?
How does it know
How does
that
it know when to close?
It
right?
doesn't have a Y signal to it.
No, it doesn't. How does it know to close? How would you explain that, Eric? Or do you care to? Or you don't want to? Because I have like my favorite explanation. You want me to just do it?
You should just use.
Okay,
your
I'll do mine.
explanation.
So, what is the superheat of a system?
Well, actually,
what is the superheat of a system that's off? Zero superheat, right? And what is a valve supposed to do when the superheat is zero? Because what does zero mean to a valve, to an expansion valve? That means that it's flooding, right? So what is the valve supposed to do when the superheat is zero? It's supposed to close, right? And it will just keep closing until it's completely shut. And so if it doesn't have bleed ports in it, then by its very nature, by its design, depending on how you design the seats, it's hard shutoff. And so it's actually pretty easy when you think of the forces inside of a valve and how that works, right? You have the bulb force, which is the opening force, right? And you have the, I said it, but I said it right. I need more sleep. Bulb force, which is the opening force, and then you have the evaporator pressure, which is the closing force, right? And so what happens to your closing force as soon as the system goes off? Like immediately. Starts to equalize, your closing force starts to skyrocket. And it skyrockets much quicker than your opening force does because that suction pressure is going to come up a lot faster than your evaporator temperature is going to come up. So that's another way of thinking about it. But those valves slam shut. And that's why, for example, you'll see cases, if you've ever pressurized a system of nitrogen and you're pressurizing it in the liquid line and it's going up, 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 and they're both going up, and then all of a sudden you hit a point and then the liquid line pressure keeps going up and the suction stays where it is because it hit that balance point where now the closing force overcame the opening force of the bulb and it slams completely shut. So it's actually it's not a complicated thing at all. It's not something that's like built into it that makes it hard shut off just by the natural design. That's how they are if they don't have bleed ports.
Yeah, and that's the common misconception too, is that the equalization line, which is named terribly,
I know.
you'll agree,
Why do they call
terrible
it that?
name.
Yeah. What should they name it?
External, internally equalized. Oh, that's the heart. It has nothing to do with off-cycle
Yep.
equalization of the system.
It's just I would prefer to call it the evaporator pressure sensing line. Evaporator pressure line.
Yeah, I think so.
Yeah, that's what you should call it. Let's change the name.
I'm for
Let's
it.
talk to
I'm
them. Let's
absolutely
talk to the
for it.
people who name things.
And they'll be like, well, actually.
Well, actually, there's a reason why we have to call it that because we're engineers. Anyway, okay, so the next thing I want to talk about is identifying liquid line restrictions, which was
Oh,
your
you
thing.
wanna talk about
No, I
that
do. I
again.
was wrong. I was wrong about this. Okay, so go ahead and describe the whole thing.
Liquid line filter, we're all taught anyway, is that if you see a system and the liquid lines restriction, or if there is a liquid line
There is a
restriction,
liquid line restriction.
you will see frost coming on the line. You'll see
At
a
least
mass
you'll see a temperature difference.
of above 4.
Right, whatever
Is,
number we
is
happen
what
to make
everyone
up.
looks at,
Yeah.
above 4.
Yeah, above 4.
But
Example, liquid line filter dryer. It's
You're-
plugged.
yeah.
You're going to measure, if it's plugged, you're going to measure a temperature difference across it. Right.
and if you don't, it's okay.
Right.
Look
Who believes
somewhere
that?
else.
Who
Like,
believes that?
Check mark. That's not the
Right.
dryer.
There's
no
temperature drop across the liquid line liquid line dryer.
It's the TXV.
It's we got ourselves a bad TXV. Like
Another
usual.
one.
Another one bites the dust. Yeah, third one on this system this week. Yeah. So, what's the problem with that, Joe?
The problem with that is as long as you are maintaining 1 degree of subcooling after that restriction, there will be 0 temp change. You can have a massive
There
pressure
won't be
drop.
0 temp change, Joe. It will be
For
insignificant.
us,
It'll
for
be
all
immeasurable.
us techs, it's 0.
Okay. All right.
What Brian's saying is, if I get scientific instruments and I test, it could be 0.0000000000023 temp drop.
Right. You memorized that number. That was good. Surprising. You nailed the zeros. Yeah.
There was 17.
Oh, okay. Yeah. All right. So.
But for us, that's 0. You know, it's down to the instrument errors at that point.
Oh yeah. Way below that. Yeah.
Because it's very common to see half or 1 degree, and it's really just the instruments. It's the sun affecting your instruments, or it's the contact of the instrument to the line. It's just so many
Infinitesimal factors
yes,
impacting that measurement.
that measurement. I was just gonna say that.
Yeah. I was trying to help you with that.
We finished each other's sandwiches.
Yeah, we do. Yeah, that's a great movie, by the way. So the point is, if you have a system that somebody's jacked a bunch of charge in, which is actually pretty realistic for a system that has a restriction, like, oh, hey, my suction pressure is low. I am not beer can cold. That therefore means that I need to add some Freon. And so they start just jacking refrigerant in it. And so eventually they can keep increasing that subcool, stacking more and more liquid in there to where that temperature difference disappears. Because you may have, and again, I was wrong about this. I thought I'd never done the math, I never looked at it, and I was incorrect. You could have 12 degrees of subcool, for example, or 20 degrees of subcool.
No, it's usually like 30 going in.
It'd be a lot, yeah. It's going to be a lot. So we'll say 30 degrees of subcool going into this liquid line dryer prior to the restriction, and you could have 5 degrees of subcool coming out with no temperature difference. Because again, there's a pressure difference, but you can't measure it. So if you had a pressure port on both sides, well, then you'd obviously see the restriction, but we don't have that on a liquid line like we do on a suction line dryer.
Yeah, especially on units with internal dryers, it just looks like a low charge.
Yeah.
When you walk up to it. So.
And so the solution to that problem is?
The solution to that problem is, A, you can add a pressure port. But if you don't want to do that, what you're going to need to do is you can do some creative things like make the blower stop to make the coil ice. And what's going to happen then is all that extra Freon is now going to be in that evaporator, and that should bring your subcooling down to very low, and then all of a sudden you're going to start to see a temp change across the dryer, if that makes sense. You can start recovering the gas.
You think that's why it does? So I don't want to go down this rabbit hole because I think this is a weird one, but why wouldn't you just get your subcool close first?
What do you mean?
So if you have 30 degrees, because you're still going to see.
You can't measure that 30 degrees, though, on cases where it's blowing your mind, because it's inside the unit. You think the subcooling is 5 because it's after the restriction.
Oh, if it's inside the unit.
Yeah.
But that seems pretty rare.
No, that's super common.
I would like on a Goodman where you have the liquid
Lots
dryer
of
inside.
Lennox has dryers inside. And
Yeah. Okay. Yeah. No, that
they got
is, okay.
check valves. They've got Yeah, anytime.
I don't think the reason why your subcool drops. I shouldn't say this because you're going to prove me wrong again.
Oh, let's do it.
Okay. That's
You can't
fine.
stop now.
Joe's smarter than me, so I don't think the reason why your subcool I don't think the reason it drops is because you have liquid refrigerant going in the evaporator coil. I think the reason it drops is because you've dropped your mass flow rate, because you've dropped your vapor density going back into your compressor.
I think it depends on the metering device too, but the thing you're doing there is you want more of the Freon into that evaporator. You're going to lower the subcooling on both ends. And maybe it is because the compressor's pumping less Freon. You got less
You
mass
keep saying
flow.
Freon, and it still bothers me. I just can't get over it.
Refrigerant.
I can't get over it.
Freon.
Who calls refrigerant Freon in everyday speak? Wow,
Oh.
very little.
Oh, who calls
I'm
it
on.
refrigerant?
I'm a fringe minority.
You're a what
I
minority?
am the fringe minority.
Oh, I thought you said French minority. I was like, do you have any French benefits? Yeah.
I just got in that habit because people just know what you mean.
Yeah.
You know?
Well, you are from Tallahassee, so
I'm a country boy.
yeah, yeah, and you will survive.
So you now
Just ignored that. Let's move on.
you could be absolutely correct. It's probably both in conjunction with each other. Compressors pumping less mass, but I do know it works. But you can also just recover if you want to just start. But the problem is you don't see that. You don't see that. You don't see that big pressure drop that's going on, and you don't see much of a temperature. You might see a half a degree on the dryer, but you're like questioning that because I don't know if the tools are that accurate. So then you're gonna grab. But you're going to look for some other signs too, right? Because it's all about, a good technician
Benjamins.
is aware of his surroundings, So you're going to be like my amp draw. My amp draw is going to be high. If that's happening,
Right.
and it's a significant problem, the amp draw is going to be high.
Yep.
There's going to be, like...
Because you're stacking a lot of liquid in the condenser, it's increasing your head
your
pressure.
suction's low.
Yep.
Your
Now, if you could get to a discharge port, then you would also see abnormally high.
But you don't have that
You
option.
do sometimes.
You don't on
Sometimes.
this unit. Because
Sometimes you do.
If you do have that option,
Because
you're
we mentioned a brand that you do have access to the discharge line. What brand is that, Joe?
Train.
There you go.
so
Bibbidi
yes,
bobbidi boo.
Yeah.
I don't know why I just said that.
Yeah. So yeah, that's a quick way to diagnose it. A lot of people, it's like struggle to diagnose if it's the indoor unit check valve and heating mode. Is that the problem, or is so? Yeah, you got to kind of be able to understand that is a quick way on a train to, and that's a really, really nice port they give you.
It is.
To be able to just quickly know, boom.
Why don't they give us
Yeah.
more ports, Let's call for more ports.
I'm with you.
Yeah, me too.
Yeah.
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 All right.
Like we should have a true suction and a true discharge like the old trains used to have on every unit.
Back in my day, we used to have ports every 3 inches.
Then they found out that cost 27 cents.
Yeah. They
And
didn't.
they eliminated
actually.
it.
Eric, I wanted to hear, do you have any thoughts on this? Like, you haven't been saying much.
You guys have pretty much covered this whole thing, and we've
Okay.
hashed it out last time of proving it on the trainer that's still
Okay,
set
so
up
you
to
feel like we've
demonstrate
kind
it.
of, all right, no, that's fine.
So-
That's fine. Kind of beat this dead horse for sure. Okay. Can I get canceled for saying that? I
Yes.
can? Beat a dead, PETA, that's right. I need to stop talking about killing things and beating things. Good point. Go ahead, Burt.
Okay, another question since nobody's asking questions.
No, it's because you keep holding the mic. No one else can.
Any thoughts on why I see so few failed compressors on a typical like Linux heat pump setup versus other manufacturers? I have some thoughts on it, but I just thought I would
Wait,
ask
so
this
you're
question.
saying you see fewer compressor failures on Linux?
Much fewer compressor failures.
I
yeah.
mean, okay, who would agree with that statement? People who work with heat pumps, who would agree with that statement? Raise your hands.
Okay, all the Linux boys, here we go.
All right, we got one. We got one.
No?
Yeah, I don't know about that.
Are we
one,
talking the Linux LGs versus the Carrier LGs?
I don't know. I haven't gone that far into thought on that. Yeah.
Or you're comparing like
I don't
your
really
Carrier
think about
LGs to
questions
the
before I
Linux
ask
scope,
them.
and that
I
would be
just
unfair.
Say what comes to the top of my head.
Yeah, I'm just
Yeah,
trying to come up with a question.
Oh, you know what I think it is, personally?
Yeah.
Is those Linux has a lot of safeties built in, don't they?
Yeah,
On the
Carrier's
defrost
like,
board.
tend to,
we're
yeah.
going to let that sucker run.
let it
Yeah,
run.
that's true.
Send it. Just send
They'll
it.
call eventually.
I was just thinking, Carrier has like an accumulator that maybe some extra protection for your Linux.
Oh, you know why too? It's
for your
Carrier's
compressor and
Carrier's not using. They're using pistons for their heating mode,
Yeah, yeah.
and that's causing some serious charge migration issues in the heating mode.
That's it.
We
I-
nailed it.
That's what I was going to say. Yeah.
cool.
All right.
So why don't you do a test?
Let's.
Can we do a test on the next one? If you started to put liquid line solenoid valves in every system with the arrow of flow in heat mode, and see if that problem gets better. Be interesting. Brian's all for it.
I'm all for it.
Just
I
have to get Jesse
just
on
got a
board.
very questionable question that somebody wanted me to ask.
Ask the
save-
question.
Ask it.
No, we're going to save that till the end. Again, remember, anybody else have questions, just raise your hand, and we will get to you.
Got one
Post haste. Okay.
He just raised his hand.
Here we go. All right. All right. All right. Just keep it PG-13. That's all. All right.
No F-bombs.
All right.
Well, we're rednecks.
No. I think. I mean, I have a reason.
Give us more.
Okay. So, what market are you in? Jacksonville. Okay. So I think it's fairly evident that when you have coil freezing, you're much more likely to have damage to your blower motor for several reasons. One would be, well, but even if you don't get a solid coil freeze, it's definitely affecting your static pressure, and you definitely have the opportunity for water blow off or water drop. So either one of those can cause damage. You have water drop events, definitely is going to be more likely to damage an ECM than it is a PSC. Yeah. Yeah, I mean, I hear what you're saying. That to me seems unlikely. It seems much more likely because the number one thing, or both things that are most likely to cause an ECM to fail are water issues, drip loop issues, condensation issues, those sorts of things, and then high static pressure. Operating under high static conditions for an extended period of time, which certainly having a coil freeze, even if it's a light frost condition, which is why I asked where you are, in really, really dry climates, you tend to not get a whole lot of freezing due to charge. But in our market, I had an argument with this guy one time who was from Colorado, and he's like, low charge absolutely cannot cause an evaporator coil to freeze. I'm like, huh, that's interesting.
I seen it.
Well,
I seen it before.
I don't know much, but I do know. Well, I mean, so I think the major difference there is that a low side leak is more likely to cause a freeze up because marginally low charge is much more likely to cause a freeze up than a significantly low or flat. Not with 410A, no. I mean, they've done all kinds of studies on, 410A is a near azeotrope, and so there's not a significant difference within that blend. It's not, you're talking half a degree under normal conditions. So if you were talking, 407C or something like that, where you would have fractionation and loss of a particular refrigerant in the blend, maybe, but I don't think so. I mean, again, I'm just sharing my opinions. I've been capitalizing on the conversation here. Yeah, blower will run longer, former cabinet. Eric, you say something. Say some words. Say talk words.
Words. Well,
Words.
The
China.
module motors, I think, just fail more in general and they're more prevalent in 410A than the older systems. So, affected by the other conditions and just the fact that they're even there in the first place versus a lot of R22 stuff didn't have it.
I think it's mostly moisture migration into that circuit board is what's killing them. Mm-hmm. So probably like on your freeze ups, everything's getting so cold, it's just going to attract more moisture and get in that module and short things out,
Yeah, electricity and water, man.
They don't mix.
No, they don't mix, which is silly because they do mix. It just causes things to get all shocky. That's what I say.
Shocking.
I got one for you. In a refrigeration system, does the refrigerant leak out faster with the system thermally on or thermally off?
System on or off?
Does the Freon leak faster?
Does refrigerant leak faster?
What side of the system is a leak?
Just
I mean, a high side.
Walk them through that, yeah.
A high side leak with the system running is going to leak faster. A low side leak is going to leak slower, typically, because you'll be changing your pressures in a way that's going to affect that.
Yeah, but it also depends. And he said on a refrigeration system. So, like on a refrigeration system, if you have like a pump down solenoid or something like that, if it's cycled off, then you're not going to have a leak at all.
Yeah, I was
if it's
purposely
pumped down.
vague, low, medium, or high temperature system? I just kind of general question. You could take it wherever.
Okay, got it. Go ahead, keep talking. You can be like Talker, Texas Ranger.
Well, I mean, I pretty much said, I mean, if you want to throw in more factors like a pump down solenoid, if it's on the low side, I mean, it could take a lot longer if it's pumping down a lot.
Yeah. High side leaks, obviously, when it's running, leak faster.
Yeah. Regardless, high side leaks just typically run the unit out of
Which
gas
is the
pretty
whole
fast.
myth. I think speaking to the myth, and as air conditioning professionals, we should know this. I don't like saying should, but we generally know this. People say things like, well, I think it leaked because it was working so hard. It's like, it leaked down faster because it was working so hard. Well, if it's an evaporator coil leak and it was working so hard, it actually would leak less. So it's not a. And also, air conditioners don't care how hard they're working. They don't think about it. They don't get
They actually
grouchy.
like to keep running.
Yeah, they're like, hey, I like this. It's kind of
Starting and stopping that kind of
Right.
makes me mad.
It's like my wife doing cardio. It's so annoying. It's like, stop acting happy about that. That's horrible. But she's like, oh no, this is fun. And it's like, stop being like an air conditioner.
How
Cut it
many
out.
air conditioners
It's
have you
annoying.
surveyed about how hard they're working? They do care, Brian.
I mean, I ask them and they don't say
They have
anything.
feelings,
They just
too.
say, oh yeah, I'm fine. I'm over here working. It's like annoying. All right.
Got another one,
Oh yeah. Oh, go ahead.
if you want it.
Oh no, I do. I do. Yeah, keep going.
Is it possible or probable that the refrigerant oil can fractionate if the vacuum is very low, like 100 microns or something?
Damn. Actually, so he's the question, as I understand it, is can you damage vacuum pump oil, not vacuum system oil, by pulling a vacuum that's too low?
Jim covered this yesterday, and they've tested it and said no. I've never personally ran enough experiments to be able to answer that. I would defer to him that has done it. And they say they pulled down to like 30 microns and not been able to do it.
And maybe that goes down to a time when oils were significantly different, maybe had different additives. But POE oil, it's not going to be volatile. It's not going to evaporate in any way or fractionate, like you said, under normal vacuums that we're going to pull. And that's all the way down to, it was like 10 microns. I mean, we're talking very low vacuums.
Because don't you think if the oil was like boiled, because you're basically
Right.
saying that you're boiling the oil, you wouldn't be able to achieve that
Correct.
low of a vacuum. It would
If
start
it
to fight
was-
against that vacuum
Right.
because it's boiling off and it's adding to that pressure.
And even then, it's sort of an unrealistic thing anyway, because if you're pulling a vacuum on the line set and evaporator coil, who cares? There's no oil in there anyway. I mean, there shouldn't be because you used a line set cleaner and you got it all out, right? And so who cares how deep you pull a line set and an evaporator coil, even if that were the case, which it's not. But then the next thing would be if you're pulling on an entire system, including the oil charge, I mean, unless you're working in some really insane low temp situation where you're running really deep, long vacuums, it's just, you're never going to get there anyway.
Yeah, you're going to struggle to really get like below 500 on a system where you're pulling on the whole
Pulling
system.
on the
Oh,
oil, yeah.
Pulling on the oil. And
Yeah.
stuff.
Especially if it's previously had refrigerant charge in it.
And it's not because you're boiling the oil, it's because you're boiling the refrigerant
Out of the
that's
oil.
in the oil.
Out of the oil, yeah.
Got one over here too.
Oh, see, we're starting to get questions.
Got a
Isn't this
couple,
fun?
yeah.
This
Actually,
is the
real
most fun
quick.
I've ever had.
Keep your questions. There's a question in the live chat real
Okay,
quick.
great.
So Harley asks, hold on, let me get back to it.
I thought you would have had
So
it
many-
memorized, like lines in the
How-
theater.
How would you suggest a newer technician who wants to implement best practices at their company, how would they do that when there are older techs, old school techs, that are resistant to change?
Eric, I'm going to let you answer first.
Just browbeat them into doing it, you know?
Yeah. Yeah, that works really well.
I mean, in seriousness, though, that can be a tough situation because, people are very resistant to change. So even if you show them that it's, necessarily a better way, a lot of time it'll come back to, if we could go specifically to like pulling a vacuum faster, they're like, well, you're taking my smoke break. So you can get pushback from ways that aren't even related really to the job. So it's unfortunately really hard to implement if people don't want to change. If the people themselves don't want to change, then they're not gonna. So
I would add though that the thing that you can control, there's very little you can control in that scenario other than your own attitude. And so if you have an attitude of respect and of service, often you can win over even the most difficult technician. And so a lot of folks who maybe listen to the HVAC School podcast, for example, they get to be kind of smarty pants about things that should be this way, should be that way. Well, have a little respect for somebody who's done it for a long time, even if they're doing it, technically wrong, air quotes. A lot of this stuff, there isn't a right and wrong way. There's best practices, and then there are practices that aren't as good. But have a little respect, show a little deference, help them clean out their truck, be willing to carry their tools, walk at a good clip, just to get off your phone, unless it's the HVAC School podcast, then listen to it anyway. No, just do those things well, and you will probably find that you win people over. I mean, that was certainly my experience at a large company.
I actually do have some input on this because
let's hear what you have to say.
A personal experience for a company I worked for that was a little.
Oh, wait, it
resistant
wasn't
to
Kalos,
change.
was it?
No, it was not.
Okay, all right.
It was before Kalos.
I was worried.
It was a real hack.
Yeah, wow.
So
that guy.
I was working for a company that was also doing a lot of old school stuff, and so I ended up just doing the stuff that I would be learning from like HVAC school and everything, and implementing it myself. And even if there was some resistance to change, I would spam my managers and these technicians with all of the other resources that I was getting, so that they knew that I wasn't just talking out of my ass. I wasn't just coming up with this stuff. And then because I was just doing it, I would purchase the blue vac hoses on my own dime. I'd get the better meter. I'd do all of this stuff, and then you started to see the results later. Fewer callbacks, quicker service times. I'm getting done. I'm able to do more calls in a day because I'm pulling a vacuum in 5 minutes. All of those things begin to sort of, they pay attention, and so hey, maybe this guy does have something to do. He is saying something a little bit, that has some validity, and so they begin to pay attention. So even if they are resistant to change, I would just say, just do it. If you have the means to do it, just do it. Try it, and then I think over time, especially because you have the discipline to do things right, people will take notice.
I really like that line, just do it. Somebody should trademark that.
Yeah.
I feel like that'd be a real moneymaker.
Yeah, it would. It would. Shia LaBeouf, yeah. You have anything to add?
I was going to basically say the same thing. I would stop trying to change the world. I know a lot of people, like you, kind of sounds like, oh, I'm listening to these podcasts, I'm going to come change the world. Slow down until you've actually gone through what a day is like doing this all the time. And you will quickly realize best practices are that, and then there's like real world challenges that you need to fine tune your, am I going to spend 3 hours letting this vacuum pull to go under 500 microns, but it's 700 now? Am I going to wait 3 hours to go from 700 to 300, and I've got 4 more calls to do? I'm going to be home at midnight or 1 a.m. You can do that if you want, but I think you'll quickly realize
that your wife doesn't care how deep of a vacuum you pulled.
Right.
I've used that line so many times. I was like, but honey, I got it down to $4.99 and
I got pictures.
A decay test. She's like, I'm divorcing you. I'm like, oh, yeah, okay. She doesn't say that much.
Anymore.
Yeah. Because I just send it at 700, that's why.
Yeah. So, but that's to say, just, get some experience in the field, and you'll be able to, but always be learning, and just do it is a great mentality. You can't control them, and don't try to change them. Unless you were to, especially when you're not the owner of the company and you're someone new there and they've got more experience there, you just, and if they specifically tell you too that, you're taking too much time and you got to change this, then you have a choice to make for yourself. But typically, like you were saying, if there's value in it, and there's a lot of value in the stuff we do, so don't think there's not value. I'm not saying there's not value in it. There's a ton of it. They will see that, and you will see slow, incremental, extremely slow changes in those old techs. to where all of a sudden they're like, yeah, I got some of them gauges. You know.
Yeah. Well, the conclusion to my story is that now this company makes True Blue hoses standard on every truck, and they've got a blower door now, and they're solving more airflow problems than the company's ever seen before. And this is a company that's been around since '47. So that's the conclusion. It did help.
So the conclusion is, you have changed the world.
Caleb.
He's like Simba being held up on Pride Rock.
I think Caleb's attitude is humble, and that takes him.
Yeah.
That's really the key ingredient if you want to.
Another thing that I wanted to point out is I know you guys, a lot of you know, guys and ladies know that at the end of every podcast I tell a dad joke, right? And I imagine that everyone who listens to it laughs about as loud as Nate Adams did back there when you guys were in the middle of talking. Did you hear him? Yeah. You didn't hear that? It was really, it was boisterous.
I thought it was when you were talking.
Oh, wasn't it? Yeah. Anyway, I just imagine that in the head. That's my spirit animal as far as dad joke laughs. Anyway, moving on. Who's next? We have some. There we go. Yes, sir.
I've got two questions. I'm often asked this question: which is the best brand of air conditioning unit? And second, is it okay to vent a vent fan into the ceiling?
Okay, bath. So you're talking about a bath fan specifically, bathroom fan. Yeah. Okay. Best brand. Is it okay to vent a bath fan into the attic or ceiling?
I think the best brand for you is going to be subjective. It's going to be someone that you can get a good relationship with your distributor. This day and age, I don't think there's going to be a lot of difference in quality between brand to brand because, they're all made from the same parts. It's going to be a Chinese fan motor, and gone is the years when Trane wanted to make a better unit than Carrier, and Carrier wanted to make a better unit than Trane. Everyone's competing for the best ratings and the lowest cost. It's like it's a race to the bottom. So I don't think that you're going to find a lot of difference. So you're going to have to find a unit that you get that's easy for you to work on, that you like installing, and you'll like certain things that I won't like about a unit, and we could have that argument till the. So it's really going to be something you get good support for, to get parts for, and you think's a good value for your customers. It's a lot to do with installation, yeah. Yeah. And as far as I think in Florida, they're not going to let you vent a bathroom fan on new homes. It's certainly not. In fact, they're starting to get really strict on vented soffit versus non-vented soffit, and they're making you put holes in roofs, or if you don't have a gable end, because they won't let you put it in a vented soffit.
Yeah.
So.
Yeah.
Well, yeah, they're saying it's going to go back up in there. So there's some code that they're trying to keep that out of the attic. So obviously, in existing homes, you're not going to have to do that on a normal change out. But are you in Florida? Atlanta? Okay, so I don't know about Georgia codes.
I don't know about the codes, but regardless, it's not a best practice. So I mean, the answer to the bath ventilation, it's a bad idea to put it into an attic or into a floor space or something like that, because you are introducing very high dew point air. So much of what we've been talking about around here is about dew points and moisture and all that, and you're basically keeping it inside the outer envelope of the structure, which can cause mold, mildew, latent load issues. So it's a best practice to get it out of the structure. And that's true of kitchen, that's true of bath, that's true of all that. And I'll just piggyback on what Joe said as far as brand. Depends on installation. It also depends on type of equipment. Like I have my favorite gas furnaces, and I have my favorite heat pumps, and they're not the same brand, and I'm not going to tell you which they are in both cases, because I'll have people get mad at me. Either way, it doesn't pay.
It's Nordyne.
Yeah, brand. Yeah, so yeah. You got me. So yeah, but it does vary on your market. If you're doing straight cool, you're doing heat pumps, you're doing a lot of gas furnaces, you're doing high efficiency gas versus 80% gas. Those all make a big difference as far as what you choose.
I love this comment about who provides the best local support. I think that
Yep, best local support. Yep. Jordan Cummings. Maybe it's because he's a rep that he feels that way, but no, it is true. It's absolutely true. Local support is really the key. That's what I would say. Local support of the brand that you choose. So you may have, for example, Mingledorff's is a carrier distributor up in kind of Georgia and North Florida, and they just have an excellent reputation, and so they make Carrier look really good because they're Mingledorff's and they have a good relationship and they make sure that you get what you need when you need it and they support the product. So that's I'm using specifically somebody who's out of market so that way I don't make people mad, but I think they're probably in your market. Go ahead.
So we're in a market similar to this, humid, hot. Does it matter what kind of surge protection you use? I heard you guys talking about it a little bit the other day, like specific ones. And are you doing anything to protect control boards, and is it working?
This is one of my favorite topics.
This is not one of my favorite. You'd probably be best on this. I'm not a big surge protector.
Surge protector?
Surge
You
protector
have anything to add?
Well, didn't you find through extensive testing that in our market it was more the voltage of the utility provider than surges in general?
Yeah.
Where we get like 250 volts to equipment, so they started installing a transformer to bring the voltage down to around 220 volts, and
a little higher than that. I mean, we're trying to get it on average, because again, these things are rated at 230. It's an interesting difference between the utility and equipment manufacturers. It's something you don't think about. But if you look at the data tag on the equipment, it doesn't list 208, 240. I mean, I guess maybe in some rare cases it does, but we're talking about single-phase equipment. It lists 208, 230, right? And so it's 208, 230 plus or minus 10%. Well, utilities do it based on 240, and they do plus or minus 5%, but not plus or minus 5% peak, plus or minus 5% averaged. So they'll feed you over voltage for significant periods of time, which results in unequivocally results in board failures in some cases, especially with inverter boards. Now, my argument would be they should design inverter boards to handle higher voltage. So go to 240 plus or minus 10% rather than 230, but they don't listen to me. They just say, you stay over there in your little hut, podcast boy, and do what you do. So our solution is, because utilities won't listen, manufacturers won't listen, and it's not one utility and it's not one manufacturer, it's all manufacturers and all utilities. So our solution is the ICM 493 acts as a single phase over voltage protection. So that way, if you have peak conditions that are over voltage, which tends to happen at night, you know why it tends to happen at night? Why you tend to get over voltage at night?
Because the grid's less loaded.
Grid's less loaded, right? And so that voltage creeps up, which is the reason why they jack the voltage up so high anyway, because they're trying to get the most out of their distribution system. So you have higher voltage, you have less voltage drop, so you can do more with it. You have more variety. And they will argue, as they often do, they'll say, well, why does this matter? It never was a problem before. We did this forever. Well, it was never a problem before because they were using PSC motors. They weren't using inverter drives in the equipment, right? They weren't using ECMs. So we only focus on the condenser largely. Can it be a problem on the air handler too? Yeah, it can. And I mean, we're starting to talk about offering ICM 493s on the inside too, but they're expensive. They're fairly labor intensive to install. They're amazing and they're very well built. But what we like about that product is it has both that over voltage protection and it has 5 metal oxide varistors. And pretty much all surge protection that we work with is some version of a metal oxide varistor. Everybody has their little extra spin they put on it. You're like, oh, well, we have a vacuum tube technology that makes them last longer. But metal oxide varistor works by shunting current to ground during high voltage conditions. So when you have these really high voltage transients, i.e. lightning strike, i.e. something going on in the distribution grid where it sends high voltage down the line, it takes that extra current and it shunts it to ground. But when it does that, they generally just fail. So that means you've got about 5 shots for it to happen. And in Florida, that happens a lot. So is that valuable? Absolutely. Is over voltage valuable? Absolutely. But the problem with most of the ones that we install in our customers' houses is we put it in and we forget it. Well, 3-4 years down the road, the thing doesn't do anything anymore because all the metal oxide varistors are used. And that's in cases where you have multiples. A lot of them only have one. Everybody went to thermally protected metal oxide varistors, TPMOV. And they did that because if you remember some brands, who will remain unnamed, that were catching the sides of houses on fire because what would happen is the metal oxide varistor would do its job. It would shunt to ground, but then it would go into thermal runaway, and the thing would just keep shunting to ground until the whole thing melted and made a big fire. So nowadays they have a thermal limit in there that protects it, so that way once that starts to happen and it gets hot, it opens and stops that from occurring. So there's been all these challenges, and there continues to be these challenges, and they're not cheap. And so you can sell it as many salespeople do, like, hey, I'll put a surge protector in here that's going to protect you for the next 10 years, bada bada bing. It's not that simple. Now, to what Eric was saying, we use buck and boost transformers to really solve the problem. If we've got a case where the utility's not listening, they're just not, and they keep feeding continuous overvoltage, and the ICM 493 is keeping the system off because of these high voltage conditions, we put a buck and boost in, we drop it down 10, 15, 20 volts using a buck and boost. And that's a buck and boost, all that means is, so to boost means to increase voltage, and to buck means to decrease voltage. And so we're bucking the voltage down, which sounds weird. You know, bucking the voltage, I don't know, sounds strange.
You potty mouth.
I know, I'm sorry. We're bucking it down, 20 volts or so to get it back into that kind of sweet spot of 230 volts.
So you feel like that's more valuable than a surge protector?
In our market, it is, because we have this problem. But is that valuable at all if we have a single stage system with ECM motors? I mean, with PSC motors? No, it's not valuable at all. It's meaningless at that point. I mean, okay, not meaningless, because if you've ever seen cases, because it also works on the brownout side, so under voltage, it will also shut it off, and you will get cases with contactor chatter and some things like that. On the other end of it, and just circuit boards in general too. This is another thing that we miss also, is when you increase the line voltage coming into an air handler or a furnace, what happens to your secondary voltage on your transformer?
Yeah, you get like 30 volts.
It also proportionally increases, and that can go above rating as well, which I think, and again, this stuff's hard to prove, but I'm quite certain it's a contributing factor to premature board failure as well. Does that answer the question? That was quite a little. Ooh. I tired myself out. No, that's all you got. You've got voltage over voltage for boards. Under voltage can help with motors, contactors, other controls, electromechanical controls and motors, and then surge protection. Those are really the three things, and it's great. It's just expensive. Like you can put inline protection. There's a lot of different things you can do, but it's like a bunch of stuff down the line that you got to control.
You're still not going to keep that frog from getting behind it.
Mm-hmm. That frog, when he wants back there, man, he wants back there. Yeah. All right, great.
So residential monitoring systems, I'm just curious, something like a Sensi Predict, I don't even know what else is out there, but does anyone find a benefit in that? I know everybody can take different, business model directions, but is that something we should be pursuing, finding the problem before it breaks, and what are the pros and cons to that concept?
Yeah, go ahead, either one of you.
I think down here, a lot of people have vacation homes that they're not in a lot, so having some sort of monitoring is definitely good in that situation, because the snowbirds, they're down here a couple months out of the year, definitely valuable.
I guess I'm always like the devil's advocate to like, if you sell someone something on the premise that it's going to do X, Y, Z, and it doesn't do X, Y, Z, you have exposed yourself to some sort of liability by telling them that it's going to prevent this. But at the same time, it's, so you would almost want to have someone that says, I've got, I may be interested in having something like that. And then you would have to decide, are you going to do this like company-wide? Are we going to be in charge of monitoring it?
Yeah, then that's the problem.
That's the challenge.
The problem is you got to commit or not commit. Like you can't do it halfway. One thing that you said that I want to address specifically is you said, should we be looking into that? Okay? And I call that shoulding all over the place. So when you tell people they should do this and they should do that, there's no should here. This is not a should situation. Measure Quick is not a should. Sensi Predict is not a should. It's a can. It's a does it work for your business model? It's a does it work for your area? Does it work for your customers? When we start to feel guilty about not doing something like that, now again, if it's a moral issue, and I would definitely say this doesn't fall into that category. If it's a moral issue, that's a different question. But this is not a moral issue. This is a business model issue. This is a question of what you can commit to as a business. And I'll be authentic. We attempted to do Sensi Predict, and we just weren't the right business model for where they were at that time. You know, it's just like employees. Some employees are absolutely amazing for somebody else, given a different business model or a different type, and they just don't work for you. And the same thing is true with Sensi Predict, which is why I have no problem promoting it and saying that I think it's great, because I think it is. I think they've done a great job integrating with MeasureQuick. I think MeasureQuick's great. We just aren't a company that's going to commit to that maintenance model. That's kind of required to make sense of that. And it just has to do with the type of equipment that we install. So, like, for example, the way that I saw it as the most likely way to implement it in our business was to do it on all new installs. That made a lot of sense to me. But the problem is it only can work on a portion of our installs because it's not going to work with communicating equipment. And could you make it work with communicating equipment? Sure, but unrealistically for a company of scale. So I think for a smaller organization where you're maybe 5-6 people and you want to really make that a cornerstone of your business early on, and you're going to commit to somebody doing the monitoring and making it part of your maintenance programs, I think it could be transformative. I think it could be really great, especially if you're going to work directly with the smart people who implement that software and make it work. But for a company of scale, you just got to decide: are you going to commit or are you going to not? But I would not say should as part of that. I'm not saying there's anything wrong with you saying that, but I'm mostly just saying I felt that way so often. It's like, oh man, I suck because I'm not using a blower door on every service call. You know, like whatever it is, especially if coming out of the symposium. But that's not the point of what we're doing here. The point is to open you up to opportunities and possibilities and use what works for your business. Oh, thanks, Burt.
It is neat though. I mean, it's very neat. You can log in and see, wow, it's been doing this for 2 days. And so it is a valuable tool. I just feel like, it's not going to be something you would just want to expose yourself offering. Just be careful maybe about what exactly the expectations are for
don't
that
be
money.
such an early adopter that you hurt your business. Because I would know about that because I've only done that like 50 billion times, right? And I'll buy this really expensive fancy tool and I'll be like, hey guys, look at this. Isn't this the coolest thing? And they're like, yeah, it's cool, but like, how do we implement this into our business processes? And I'm like, I don't know, you'll figure it out, and I'm going to buy 40 of them. Woohoo! And that's not how you do it, right? That's not the right way to do it. The right way to do it is to think it through, come up with a plan, and then work the plan. Go ahead, Tony. Yeah, for intermittent issues, use it as a tool. That's a possibility. Now, they're not really set up for that, so it's kind of tricky, and there's a lot of competing products hitting the market right now. I think they probably have the best product on the market right now. I'm big fans of Emerson and the stuff they do, and that team I'm a huge fan of. So yeah, I think it could be used in that way, and that's where you just got to be innovative. You got to look at it. If you really want to use it, think about how it's actually going to work for you. Because ultimately, it's got to be good for your customers. It's got to work for your employees. It's got to be something that they can implement, and you got to be able to make money doing it. And you got to be able to make the same or better margins than you're making doing other stuff. Because that's often the mistake that we make when we're like, I love building science. It's like, great, that's awesome. Are you going to make less than what you were doing before, margins-wise? Because if you are, you got to be pretty darn idealistic, and you got to be willing to take that hit. And the truth is, you may think you are early on, but the reality is that once it starts to affect your family and your employees' families and what they can bring home, that's a scary conversation to have. We got a mic, mic in the back there. Sorry, I set a bad precedent by saying that one. But
in what application is it a must? You hear some manufacturers, if you've got a scroll compressor with a TX valve, you need to have it. If you've got other applications, is it because some manufacturers they'll manufacture their own and they require their own in there. Others, so many different brands and so many different designs between start kits. Mm-hmm. Just that conversation.
Burt knows that this is one of my favorite topics, so I'm not going to start by talking. Go ahead, you two.
Well, the must situation is reciprocating compressors that has some sort of hard shut-off TXV or pump down solenoid. You're not going to get reliable starting without them. But as far as other situations, I see them used a lot of times to overcome a compressor that's on its way out. Most often, that's typically where I see them used, right or wrong. That just seems to be, besides the ones that need it, that seems to be where I see them.
Yeah, and I think there's a lot of not scientific salesmanship practices that say this is a compressor saver, this is a energy.
As in, that's the name that they put on the box.
You went there.
Yeah. Go ahead.
But or this is going to.
Like, where'd you get that idea from? Well, it says it on the box. Sorry, keep going.
And I fell for it.
Yeah.
Hook, line, and sinker. It's like, yes, it made sense. Like if I'm going to be pulling locked rotor amperage less, it's going to be better for the windings. But is it better for the crankshaft and all the mechanics in that compressor to have a more violent start? It's, subjective. I mean, I don't think there's like solid evidence to say one way or the other. And another thing that bothers me about scrolls is they don't publish any start capacitor sizes. It says literally NA, not applicable, when you look up any. Like, let's say you got a ZR24 K5, and you want to see, you can find the run capacitor. What size start capacitor? Nothing. They don't give you that. So
I think some cases the manufacturer will give it in their long.
How did they get it if Copeland doesn't give it to them?
Well, I don't know that. I mean, I think they have a cabal of people who sit in smoke-filled rooms, and they have red telephones, and they call and they're like, "Hey, what type of?"
I don't know. Either it doesn't really matter that much, or they're like, well, this is a 3-ton unit, so let's put that 3-ton 521. Yeah.
So, go ahead, Garrick.
I was going to say another place I've seen people use them a lot is to try to get units to run on a generator. Have you guys seen that, where people are saying maybe it'll run on the generator with a start kit?
You would recommend it?
I think I would.
You shan't.
Okay. Do tell. You
shan't. Okay,
The
so
soft start
I'm going to
thing?
do this really quick because we need to wrap this session up. This is like my favorite topic. Burt knows. Okay, so what does a hard start do? What does it actually do electrically? Yeah. Okay. So that is the patent answer: phase shift in the start winding. And people imagine that somehow it shifts it more, right? It's got more of a shift because there's a bigger capacitor on it. But really, what it does, because a run capacitor already creates a phase shift in the start winding, a continuous phase shift, right? What does a start capacitor do that's different? What it does is it allows a temporary increase in current on the start winding, a significant, generally, temporary increase in current. Now, some of you are thinking, that's wrong, okay? And I'm fine with that. Please go research it. I've written like 47,000 articles on this. That is what it does, okay? When you increase the current on the start winding, does that make it more or less likely that the start winding is going to fail? It makes it, well, it's actually not an easy question to answer, because by increasing the current on the start winding, the argument is that it starts quicker, right? So, and so you're right with what you said initially, but here's why people would argue with me about it. They say, but, Bryan, I measure start amps on this compressor, and I see that it draws higher amps when it's starting, right? Duh. So if I can get the compressor to start quicker, that's good, right? That should help save the start winding. Stand to reason, right? Well, let me ask you this. What happens if you take your run capacitor out of the circuit and throw it in the grass and you don't put a hard start kit on it? What is the current on your start winding? If you have no capacitor in at all and you just leave that wire dangle, what is your current on your start winding? It is 0. What's your start amps on common when you have no capacitor? Hint, you've seen this happen before because capacitors fail all the time, right? And what does your compressor do? Have you checked that current? It's still high. How does that work? You can have 0 current on your start, and will your start winding fail under those circumstances with 0 current on it? The answer is no. So which winding fails? It's the run winding. So where is start current, locked rotor current, occurring? In the start winding or in the run winding if you don't have a hard start kit? The answer is in the run winding. That's where you see it. Just check it next time. Check your run winding current, check start winding current, see where they're at, right? So what does a hard start kit do? It allows start winding current to go way up at the beginning. So does your compressor draw instantaneously more current or less current with a hard start kit in? Answer is more. Quite a bit more, actually. But it only happens for a very, very short period of time. So short that most meters can't pick it up. So when you measure on common, you see, oh man, this saved me a lot. It dropped my current, right? Now, is that a bad thing? No, not necessarily, because it did drop the current on your run winding, meaning that over a time average, because it gets out of that start phase quicker, gets out of lock rotor quicker, it actually does save some heat, right? So it's not all wrong, but it's very complicated electrically. So what's the worst thing that can happen with a hard start kit? Anybody know?
The potential relay welds
The potential relay welds shut, but it doesn't even need to weld shut. It could just not open fast enough.
Or the run capacitor fails.
There you go. There you go. And that's another circumstance. And that's why Amrad developed a hard start kit with that special terminal that you connect to your run capacitor so that if your run capacitor fails, your start capacitor also does not come in.
Very smart.
They're the only ones who did that. I'm not going to say who their consultant was at the time when that was designed, but it was somebody who has a really good podcast.
Does it rhyme with Brian Moore?
No, I don't know what you're talking about. So what that does is the hard start kit does is it creates this big spike, and that's not a universally good thing. It's a good thing if it's designed for it, and it's a good thing if your run capacitor is working, and it's a good thing if the potential relay opens at the right point, and it's a good thing if your potential relay contacts do not stick. So why should you not sell it to every customer as a compressor saver? Because it's not a compressor saver. It's not going to help save the compressor if it's not needed. Now, there's going to be people who, if they hear this, they're going to send me emails. And they're going to say, well, we've done the test. I'm not saying it never does. I'm just saying that the only way to reliably get this right is to just do what the manufacturer says. The compressor manufacturer, the OEM of the equipment, that's the only way to reliably get that right.
Or there's circumstances where it is the lesser evil.
Oh, sure, yeah. You got a locked compressor? Yeah, absolutely.
Or a brand new system with 208 building, big 5-ton single-phase system.
Yep.
That may be, you don't want to leave the job,
right.
And 1 out of every 10 starts, the compressor's pulling locked rotor. That's, way worse than what could potentially happen with the start.
Right. And that's why we have kickstarts in our warehouse here. I'm not saying that they're the devil. I'm just saying that the reliably, something you sell to somebody as like hey, this helps, the only way that works is if the manufacturer said you needed it, and that's why you put it in. I forgot who originally asked the question because I talked for so long. I lost my... Cool, yeah. Does that answer the question? I mean, it doesn't. It's a very complicated thing, but yeah. Well, no. What? Go ahead.
Do you know why?
You tell.
Train uses what
I know.
sort
I just want you to. I want to hear
of
you
metering
say it.
device in the outdoor unit? What does Train use in the outdoor unit for metering device? TXV. And Train uses a lot of reciprocating compressors still. So that's why it doesn't matter what the indoor air handler you were going to have. That's why it's in the... interestingly enough, though, for some reason, Trains will not start even when the pressures are equalized because the indoor unit's a piston sometimes when that start capacitor goes. So it's something that they've done with like the climate tough compressors where it really needs that. I'm sure you found it where maybe someone told them they had a bad compressor on a Train and it was just the start capacitor was bad. And the pressures were completely equalized. The compressor would not start.
Yeah, and that's because it's engineered and designed for that. It's part of the engineering of that compressor. So, and I have no issue with that. I'm not saying that hard start kits or start capacitors are a problem. I'm just saying it's not. It's like anything. It's like internal leak sealants or UV lights or bipolar ionization or any of these things. It's like if you start throwing it at everything as though it's a solve-all for a problem, regardless of the equipment type, regardless of what the manufacturer says, you're probably doing more harm than good. And does that mean you're doing a lot of harm? Maybe not. Because even companies like Kickstart and CPS who make these things, they do some engineering to attempt to kind of match it up with universal compressors. But they're always making sacrifices. And they'll tell you that if you ask. They're making sacrifices. They're making educated guesses. The engineers will tell you that. Marketing won't tell you that, but the engineers will. Always ask engineers these questions because they'll be honest with you. And quick caveat there too, marketing's not being dishonest, it's just what they know. So I'm not saying anybody's lying. Again, my lawyers told me to say that. All right, so we're going to go ahead and wrap up now because we end at noon, right, Caleb? So I'm going to give everybody a chance to kind of, anything else you want to add, Eric?
You said you had a very inappropriate one that we were going to cover later.
I'll just read it. Yeah. I'll read it. So this question comes from Bill Spone.
Really?
Well, that's what it says. It says this comes from Bill Spone, but the person who actually sent it to me is not Bill Spone. It says, this question is from Bill Spone. If you and Jim Bergman were to conceive a child together, and you both decided to co-parent amicably, what would that look like given the long geographical distance between you both? Also, what if after all that, he became a plumber? So, you can see why that's inappropriate for many reasons, mostly because it says plumber in it, and I just can't, I cannot abide that. The rest of it sounded fine.
It'll be something we'll ponder for next time.
Yep. Unfortunately, I think that I'm probably the wife in this situation.
Wow. Wow.
You just gotta look. You know thyself. That's the key here.
Hey, this day and age, If
you've listened to our podcasts, oh no, actually, he's the one who does all the talking. He's definitely the wife. I'm like, yes, dear. Yeah. I feel better now. Woo. I'm definitely canceled now.
Seriously. Whoa.
If I
they're
wasn't
coming
before,
for you.
Wow.
They're coming for you with that joke.
Anything else, Eric? That's it for you? I'll let Joe finish. From my standpoint, all of this stuff is it's not about accumulating knowledge. Sometimes I'll go off and spout about all this weird stuff, but the reason why I like it is because you're trying to solve a problem, right? It's all about solving a problem. You run into a problem, you hear something, you're like, is that true? And then you find out, oh, maybe it's not true. Why did this fail? Why are we having these issues? So do that, pursue that. And don't just pursue it with people like me. Talk to your manufacturers. Talk to the engineers within the companies that manufacture your equipment and that sort of thing. If you get people who actually know a lot about how products are made and all that, you'll get some really good answers. So don't always stop with marketing. Don't always stop with tech support. If you've got something that you're struggling through, get the answers you need.
Yeah, it's great. I've been to every single symposium there ever has been.
That's 3 whole symposiums.
That's 3 whole symposiums. Yeah. And I always love it. I look at you all like brothers, and we have something that we love in common. I love talking about it, and be happy to help anyone in any way. You do? Yeah. Is this recorded?
It is, yeah.
Good.
It is,
okay.
Yeah.
But, I leave this symposium every year highly motivated, and it really has been great. And then you get back to real life, and it's June now, and
it's February. I just wanted to make sure you knew it's February.
I said
it's June now.
Okay, I'm telling a story.
Okay,
Bryan.
sorry, I'll be quiet.
Jeez,
I'll turn my back on you.
Okay, so you leave here in February, but then some time goes by, and it's now June, and you don't feel so motivated, and it's just a grind. And we all love HVAC, but HVAC isn't everything. So I just wanted to encourage you guys that there's something way more important than anything we could ever teach you about HVAC. And it's about the Lord Jesus Christ. Would be if, I'm not going to preach at you, I promise. But if you think about it, what year is it? 2022? And it's the same in China, all over the world. 2022 AD. And before AD was BC. before Christ and after death. So we're counting time by this guy. It might be worth checking him out. You know, don't take anyone's word for it, but there's manuals that will be more of a blessing to you guys than any manual about HVAC you'll ever read. And I've got a couple up front if anyone was interested in. It's a great translation, super easy to read. And I'll just leave them up there sitting there. If anyone wants one, you're more than welcome to have one. I'd love to talk to anyone about HVAC or anything. Don't feel shy. So,
yeah,
thanks
great.
for coming.
No, I really appreciate that. Yeah.
Thanks for watching this video. Again, to find out everything we have going on, you can download the free HVAC School app on Android or on iPhone, or go to hvacrschool.com. And then specifically up in the top, you'll see events to find out more about upcoming symposiums. Hope to see you there.
Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.